conditioning system. So you can see here, this is a figure for the air conditioning system. So there's a lot of component in the air conditioning system. So what is air conditioning? Air conditioning is the process of altering properties of air, primary temperature and humidity to more favorable condition. Favorable condition as in you want to have a very comfortable condition. So why is the control of air important? So this is to maintain the health and comfort of the occupant and to meet the requirement of industrial process irrespective of external climate condition. So air conditioning is there to adjust the temperature in the room to a optimal condition where we feel comfortable. So in Malaysia, we have cold air conditioning. Means is blowing out cool air into the room because we are in a hot country, so we do not have the hot air conditioning. So in a cold climate country, they actually have a hot air conditioning. Means instead of the aircon blowing out cool air, the aircon for in a cold country or a heater, they are actually blowing out hot air into the room because the outside temperature is very cold, maybe at 7 to 5 degrees or maybe up to 0 degrees. So we have a optimal comfortable zone which is about 20 to 25 degrees Celsius. If it goes lower than that, then we'll want to try to adjust the temperature in the room to be at that zone so that we'll feel comfortable. So this is why air control is important. Even if you are in the hot country or you're in a whole country, there are ways to control the environment. We have the means to control the environment through technology, which is air conditioning. So what is the principle of air conditioning? Is to keep us comfortable inside the house compared to outside. So if you are warm outside, like in Malaysia, we are a tropical country, we are warm 24/7, and then at noon there will be 30 degrees Celsius, which is blaring hot. Then we want to stay in our room or in a house which have air conditioning. Either that or if you are at overseas and it's very cold, you want to enter into the room which has a heater. So it will warm our body up. So this is why air conditioning is important. So if you look at the figure here, this is actually a refrigerant cycle. So I've covered this before. So it's basically this four component. So I won't go into it. I have to refer back to the slides previously. So the objective of air conditioning is to provide and maintain internal air condition at a predetermined state, regardless of time, year, season, or external factor. So air conditioning must be able to maintain and control the moisture content, remove the impurities or pollutant, and remove heat. So this is the function that you are required for the air conditioning. So the controlled environment condition in any AC design includes dry bulb temperature, moisture content, air movement, and air quality. So air quality is achieved by means of a good filtration system. So every one of us have air conditioning, I think. So its function is to provide a very comfortable environment for us to remain in the room. So most air conditioning perform the following function. So this is a repeat again. You are to provide a cooling air, a clean air, we distribute the conditioned air, and then control and maintain the indoor environment parameter. So this is the function of this for air conditioning. Later. And then there's a benefit of air conditioning. So in different environments such as factory, office, so the usage of air conditioning provide benefit such as in this area. When the area is cool, the people inside will feel comfortable. When people are comfortable, they will feel healthy. And if they are healthy, they will be able to work properly, efficiently. So output will be increased. So there's a lot of benefit by installing it at different area. So you want to have a comfortable area, you want to have people stay longer in your area, then you install air conditioning. So for air conditioning, usually if you go to buy air conditioning, you want to have it the rating will be in terms of tons of HP, which is horsepower. So this is to determine how powerful is the air conditioning system. Either that or the British Thermal Unit BTU. So this is just for info. Next, so there are few types of air conditioning. So the first is the window air conditioning system. So I think this is phased out. We won't be seeing this anymore unless you are living in a very old house. Then you will have this window air conditioning system. So all the component in the refrigerant is actually located inside this window air conditioning system. So this is old technology. I'm not sure if you guys seen it before, but it will be quite hard to find this type of air conditioning system anymore. So the second is a split air conditioning system. So this is basically what you'll find in your room, in small room. So you have a air conditioning unit, and then you have a refrigerant unit outside. And then this here, the next one is the centralized air conditioning system. So you'll find this in mall or in offices. So between 2 and 3, you'll find 2 in houses and 3 in commercial building such as mall, for example, or office. And then for this, the last one is a packaged air conditioning system. So this will also be found in something like a mall or a theater. So 3 and 4 is commercial usage. 1 and 2 is for residential usage. Okay, so the different type of air conditioning. So for room, you have the split unit. So this is it, like which is the second one, which is the split air conditioning system, and then the ceiling cascade. So this is it, and then the second part is the central air conditioning system. So this is more towards commercialization of the air conditioning. So this will have higher horsepower because it's used to cool down a very large area. That's why you have a central air conditioning. You have a bigger refrigerant cycle system installed in this. So the first is the for room, and then as it goes higher, you'll find that it's for commercial purposes. So a room air condition is comprised of an outdoor unit and an indoor unit. So outdoor unit is used to host the component like compressor, condenser, and expansion valve. So this unit here is where all the changes of heat occurs. So compressor will compress the air at condenser. So at condenser, heat will be released, and then at this expansion valve, they will reduce the pressure of the liquid into gas, and then you'll go to the evaporator. So evaporator is the area where the indoor unit, which is your aircon, is blowing the cool air into your room. So their their rating is about 1 to 4 ton for residential usage, which is more than enough for small room or office space, and is cheap. And but the problem is the efficiency is lower than the central air conditioner. But one thing good is cheaper than central air conditioning because you do not need a very big air conditioner if you only have a very small space. That's why you pick what sort of air conditioner you want to install in the area depending on your usage. If you're using it for a long period of time and if your area is very big, you want to install something like a central air conditioner. But if you're only trying to reduce the temperature in a room, maybe for a few hours a day, then you will be better off installing a room air conditioner. Because if you only want to pay for what you use, that's why it's better and cheaper to install a room air conditioner in a room. And also it's less expensive to maintain and to invest in. So there's different type of air conditioner, the split unit. So you can have a single split wall mounted, or you can have a multi-split wall mounted. So most of the case you'll see will be something like a single split wall mounted. So you have an indoor unit, this is your aircon, and it will be connected through a pipe to an outdoor unit. So all the heat will be expelled here. Either that or they have a multiple unit, but essentially it's still the same. Each outdoor and each indoor is connected to the same place. Next is the ceiling casket. So this is basically a centralized air conditioning system. So they are used to serve more than one room or a very big area. The usage is the same. They are to use it to cool down the air, and then they have a same component in the packaged air conditioner. So they this is the refrigerant cycle is the same. So no matter what you go, if you would want to cool a room or an area, all these four components is the same. So here we have an evaporator, condenser, or compressor. So they have omitted it. They have omitted the expansion valve out. So, but it's also very still important the expansion valve. Okay, so because central air conditioning is for commercial purpose, they are required to cool a bigger area. So for sure they are loading the heat, the BTU, the British thermal unit is higher, or the tonnage is higher, or the horsepower is higher. So they can be go up to 3 to 20 tons. You usually find this centralized air conditioning, which is for commercial purpose, at a restaurant or a mall. So if you are using it over a long period of time, it is more efficient compared to the personal air conditioning you have at home. But of course, if you use more, then you will have to pay more electricity bill. So this is the next one, which is the all air system. So this is the same like the previous one, which is the central air conditioning, but instead of the central air, this is used to cool down an even larger area. So that's why at the second line here you see that there's a cooling load. This extends beyond 20 ton because it's used to cool down an even larger area. So there is 6 components with it, which is a supply duct, the fan component, flexible connection, heating and cooling coil, filter compartment, return and fresh air duct. So this system is improved using cooling tower. So in large building, they will have a centralized air conditioning equipment. So usually here is stated that roof and basement is a choice because basement you have an advantage of easy utility connection, noise isolation, and not valuable rental area because people do not want to rent the area downstairs. And because it's at the bottom, so if you are to put a very heavy equipment on it, so there will be no problem. But usually you want to put your all air system on the roof. So why you want to put it on the roof? This is because as you exhale out the heat and you will be able to expel all the heat into the environment instead of having it trapped in the basement. So you can have it in the basement, but one of the advantage of having it at the roof is nobody's gonna use the roof if it's a commercial building, and then you'll be able to expel all the heat and you'll be able to draw in the fresh air and push it into the room. So instead of having a ventilation system, we can have the air conditioning getting the clean air and having a mechanical inlet and pushing all this clean air into the building. So there will be a two-in-one job. Instead of having ventilation, you have this air conditioning system. So this all air system is still the same. They have this heating and cooling coil. So it's like the refrigerant cycle. So this is a picture of how this air handling unit works. So this there's two different arrangement of this air conditioning system. So the first one is the air handling unit. So we have a cooling tower and a refrigerator machine. So a refrigerator machine, this is where all the air, cool air is expelled out. So you have this area where the air, the gas, the refrigerant gas is being cooled down and wind is being pushed out of this air handling unit. So as the air is traveling through this duct work, the cool air will be able to circulate all around the building. So why do we want to have why do we want to only use air as a medium? Because air by itself is very light. So if imagine in this case, if you have water or the refrigerant tubes going through all these area. So if you have all this refrigerant tube, then you actually need to reinforce all this ducting because gas or liquid by itself is very heavy. So if you're only moving around air, which is very light, then you do not need to have a lot of work done to make sure all these components are in place. So that's why we want to handle air instead of liquid. So we want to have cooling tower here so that you'll be able to exchange the air, and then all the hot and humid air will be go out onto the environment. And also because all this cooling tower and refrigeration machine is equipment, so they themselves will generate noise. So if you're on top of the building, there will be no problem with it being cooling. But if you're at the bottom of the basement, then you need to make sure your basement is air noise proof. So for this, the next one, to instead of having a big air handling unit, we can actually install separate air handling unit for each floor. So with this, you only need to circulate the water vertically. Means you have a refrigeration machine here, which is the same as the previous, but instead of only having one big air handling unit, you're making it at here. So with different air handling unit, you'll be able to control the different area, the temperature at this different area or different floor. So we do not want to have ducting all around your building. You only want to have air handling unit instead of all this ducting going around all your building, and individual different fan to blow the cool air. So as of now, there's only two sort of configuration. Mainly we want to only move the air, because if you are to move water, then you need a pump. You need a very powerful pump. So if you can see here, for this first configuration, there is no need for a pump, because the distance from the refrigeration machine to the air handling unit is very close by. But in a case where you want to install air handling unit at different floor, maybe just this is to control the temperature at different floor, then you require to install an additional pump. So this is to drive the refrigerant liquid gas into the air handling unit. So at this place, the air handling unit is where all the cool gas is being fanned out into the floor. So what are the advantages of having all this installation on the roof? You'll be able to do maintenance in an unoccupied area. So because you do not have any drain piping, because you're only moving, or you're moving air, so electric equipment, power wiring, and filter is all within the conditioned area. So you do not have any component at different area. Then you offer option for use of outside air instead of mechanical refrigerant. So you're basically cooling the outside air and pumping it into the building. You'll be able to distribute the air. So instead of having a personal air conditioning system where only that particular location the air is being cooled down, because you have different outlet. You can see here, this is one of the outlet, this is another two. So this is only a 2D view. But in actual, there will be a lot of distribution outlet to blow the cool air. So with this numerous distribution outlet, you'll be able to cool all the surrounding air evenly. So it is best suited to application requiring high exhaust and makeup air. So this is for large area. And then least interference from curtain blinds at window. So you will not make any disturbance to the curtain blind or the window. Then the last is there's no hazard to damage of furnishing in occupied area. So because you're blowing the air at a very low pressure, although there's changes in air, but you are blowing it at a very low pressure and evenly across all the building, so you will not be doing any disturbance or hazard to the area. But there's disadvantage to it because it's a large area and you have all these different you have a lot of distribution outlet, then you will need additional duct space. So this duct space can be used for floor space or you can increase the height of the building. And then accessibility might be a problem because the diffuser is located on top of your ceiling, so you need to climb up and maybe to service it or to replace it. Then air balancing in big system are more difficult. So if you have a blockage or you have a problem, then it will be difficult to fix it because it's a more complex system. And then if you and then there's also the inability to accommodate changes in building usage. So what it means that if you have additional partitioning, let's say the room is already the room is made this way, but you want to split into two, but there's a problem because you cannot accommodate to the change because your outlet is permanently there. You cannot just suddenly just shift your distribution outlet. Let's say from one room you want to make it into two. So you cannot just simply say, oh, let's have a new ducting. It doesn't work this way because your ceiling is already concealing the duct. So if you want to add new distribution outlet, then you will need to do a lot of hacking. So it's not very accommodating if you want to change the building usage, maybe from a restaurant to an office, then it won't really work if you want to add new partition. Okay, so this is it for the air conditioning. So basically for air conditioning, you know that there is two. One is residential, another one is commercial. And then you have know the component on this. The next is you know why you want to move air as opposed to water. The idea behind air conditioning is using the technology of refrigeration cycle. Okay, so the last and final is the ducting design. So how to design a duct system? So a ducted air velocity. In the ducting design, the greater the ducted air velocity, the smaller the duct size and the less space consuming the ducting. So this is the ducted air velocity. In different area, you want to have different air velocity. So volume of airflow of a duct can be calculated by multiplying the velocity of airflow with cross-section area of duct. So Q equals to VA. So Q is the volume of airflow, V is the velocity of the air, and then area is A, which is the cross-section area of the duct. So you know that for mechanical supply and extract ventilation system, the air volume flow rate can be calculated from the following formula. So Q equals to room volume multiplied by area, and then this will be divided by second, time in second. So we go into this. So question 1, this is an example. A mechanical ventilator is providing 6 air change. So this is important. 6 air change. So in an hour, you want to have 6 changes of the air in the room 6 times. Then the this is the dimension of the hall: 100 feet, 65 feet, and 20 feet. So average velocity of airflow in the ducting system connected to the mechanical ventilator is 5 meter per second. So you want to calculate what is the diameter of the main circular duct required for the room. Okay, so this is the important formula 1 and 2. So okay, going to the answer. So you want to convert the feet into meter. So you just divide it by 3.2. Same for 65 feet. This is after you divided by 3.2. So you get these three value, which is the height, the width, and the length. So you know that Q is equals to room volume. So by converting this feet into meter, you'll be able to get, and multiplying all this value, you'll be able to get your room value in meter cube. So meter cube, you multiply all this length, height, and width, then you'll get your room value. So with Q, you know that Q is equals to velocity multiplied by cross-section area of the duct. So here, you apply this formula to here because you know that Q is this value and you need 6 changes of air per hour and time in second, which is uh, this is in 1 hour because air changes per hour is 6 times and you want to change it to second because your mechanical ventilator is 5 meter per second. So you want to convert it into everything into second. So that's why this 3600 is multiply of 60 times 60, which is 60 minutes multiplied by 60 seconds. Then you will get your time in second. So this time is hour of, if is 1 hour of second. So this will be 3600 second. So you multiply the room volume with the air change per hour, and then you divide it in second, you get the Q. So the Q is your volume of airflow. So how your this is the first step. So you want to find what is the diameter of the main circular duct required for the room. So the diameter is this A. So by putting the formula in, which is QA, you want to find what is the area. So for a circular duct, you know that the formula for a circular is pi d squared over 4. So pi is a constant, which is 3.142, and d2 is the diameter. So you simplify this up, you'll get a constant d squared. And then this is a second formula, Q equals to V times 0.754. So the next one is this 6.1 equals to this. So take note at this area because this Q and this Q is the same, and you are required to find this part 1. So this part 1 will give you the requirement of the room, how much airflow is required. And because you know that you're using this formula, so you have to take this and you plug it in. So this formula is essentially Q equals to velocity and area. and And because the question is asking you to calculate the diameter, so you'll be using this Q equals to VA. But to find out Q, you need to use the top formula. So what is the requirement of the building of the room? So you know the room has this sort of dimension and these 6 air changes, and then it's in meter per second, meter cube per second. So this equals to this equals to velocity times with the area. So this area is the main circular duct. And then this VA is the V is the mechanical ventilator, which is 5 meter per second. So by putting all this value in, you are to solve the D. So once you put all this value in, this is your room requirement and this is your changes of the air, and then you solve the D, you get that D is the diameter for the circular duct is actually 1.25 meter. So you just plug in the formula and then you solve what is D. So on to the second example. For here, it's asking you what is the maximum air change that can be provided if the velocity of airflow in the ducting is 3.5 meter per second. So you have Q, V, and A is the same formula. So you know that your room, so this is in meter, you do not have to change it. And then you are given your diameter circular air duct. So you do not have to solve for it. You just plug in the value. So your room is 20 times 10 times 3. So you end up with 600 meter cube. And you are given the velocity equals to 3.5 meter per second. Then you have this, you use the area. So you have to find the area. So this is maths. The formula will not be provided for this area. You can use pi d square over 4 or pi r square. So if you are using pi r square, do note on the wording. So this say diameter. So if you are using radius, you have to divide this by 2. But essentially, the pi r square and this pi d square over 4 is the same thing. So continuing on, so for the area of the duct, because they give you the value for the diameter, you plug it in and then you have 0.159 meter square. So because you know the area and the velocity, so it will be Q equals to the area multiplied by the velocity, then you have 0.557 meter cube per second. So because you are working backwards to get the air change, you know that you have gotten that 0.557 meter cube per second is your volume requirement. So you plug this in and then 600 meter cube is your room volume. You have to find your air change, which is divided by the hour in second. So by solving this equation, you get that the maximum air change that you get with this system in place for this sort of room will be 3.34 changes per hour. So your air in the room will be having a air change up to 3 times per hour. So your room is basically having a fresh air every 20 minutes. So this is it for the ducting system. So ducting system is basically these two formula, and then it depends on either you're being asked for, like in example 1, to calculate the diameter, which means here, this is where your diameter will be at. You know that Q and this Q is the same. So you can basically take this both Q out and put a VA over here. Either that or like example 2 is asking you to find the maximum air change. So air change will be here. So you have to, for this topic 1, the important thing is these two formula. So depending on what the question is asking you, either to solve the diameter or the air change, then you'll be able to find it here or here. This Q is the same. Okay, so that's about it for topic 1. So hope you guys understand.